Define subsets. Set A is a subset of set B if every element of set A is also an element of set B. The relationship is denoted with this symbol. This reads A is a subset of B. Consider the set A equals red, yellow, blue with 3 elements. The largest subset of this set is the set itself. So, if you take a look, we can say that the set red, yellow, blue is a subset of the set red, yellow, blue because every element of this set is also an element of this set, so it fits the definition to be a subset. Red is an element of this set also, yellow is an element of this set also, and blue is an element of this set also. A proper subset. So set A is a proper subset of set B if every element of set A is also an element of set B, but not every element of set B is an element of set A. This relationship is denoted using this symbol. So this means that a proper subset cannot be the set itself. So if you have set B and A is a subset of B, that means you can denote it, or you can illustrate it this way, where the circle representing set A is fully enclosed within the circle representing set B, showing that every element of A is also an element of B. Let's consider the set red, yellow, blue again. Let's call this set A, and let's look at this set C, just red, blue. The elements of C, which are red, blue, are also elements of A. However, yellow is an element of set A, but is not an element of set C. Therefore, C is a proper subset of A. Denoted, C is a proper subset of A. This is how you would denote that. So what they're saying is C is a proper subset of A because every element of C is also an element of A. Red is an element of A. Blue is an element of A. But there is an element of A that's not an element of C. Yellow. Yellow is an element of A, but not an element of C. So while C contains everything A does, it doesn't go the other way. So in this case, we would say that C is a subset of A. As you can see, this is how you would denote it. This is how you'd illustrate it, sorry. So the set C contains just blue and red, which are also in set A, but set A contains yellow, which is not in set C, so it wouldn't go in the circle. Let's look at the number of subsets that this set actually has. We've seen 2 of them so far. So let's find all the subsets of set A. How many subsets are there? Well, there's a formula we can use. The number of subsets of a set is 2 raised to the power of the cardinality of the set. So since this set has 1, 2, 3 elements, that means that the number of subsets is going to be 2 to the 3rd power, 3 being the cardinality of set A. 2 to the 3rd power is 8. That's 2 times 2 times 2. And we can list all 8 subsets. What we can do is, first we'll list the set itself, which is set A, red, yellow, blue. Remember, A is a subset of itself. Now we'll look at all the proper subsets by taking individual elements out. For instance, if we take out blue, we're left with just red and yellow. That is a subset of set A. If we take out yellow, we're left with red, blue. That's the subset that we called C previously. That's a proper subset of set A. If we take out red, we're left with yellow and blue. And that is also a proper subset of set A. Now we're going to take out 2 elements at a time. So first we'll keep red and take out yellow and blue. This is a single element subset of set A. So this set with just red is a proper subset of set A. Also, if we take out red and blue and we just leave yellow, this is also a proper subset of set A. And if we take out red and yellow and just leave blue, then we have this set with just blue is a proper subset of set A. We can also go ahead and take out all 3 elements, red, yellow, and blue. If we take out all 3 elements, we're left with an empty set. So the empty set is also a proper subset of the set red, yellow, blue, because it's the result of taking every element out. Every element of the empty set is also an element of set A because the empty set doesn't have any elements. So this leads us to a formula. The formula for the number of subsets of a finite set A. And this is going to be equal to 2 raised to the power of the cardinality of A, the number of elements in set A. So the number of subsets of A is 2 raised to the power of its cardinality. So calculate the total number of subsets of this set D. Well, this is the set of days of the week. Monday, Tuesday, Wednesday, and of course these ellipses stand for everything between Wednesday and Saturday, which would be Thursday and Friday, or represented by these ellipses. Then we have Saturday and Sunday. So those are the 7 days of the week. So it turns out that the number of elements, or the cardinality of set D, is equal to 7. Set D has 7 elements. So the number of subsets of set D, will be 2 to the power of the cardinality of D, which is 7. 2 to the 7th power is equal to 128. That's 2 times itself 7 times.